We have Anjana and Hina who will be leading us in a conversation about our favorite thing, building scalable solutions with SP API. We'll let them take the lead from this point forward, but just want to introduce them to you all. They've been great teammates of mine and hope you enjoy them as well.
I think I have this one. Good afternoon, everyone. Hope all of you are having a great day so far. Thank you for being with us here to learn more about building robust and scalable solutions with selling partner APIs. In this session, we are going to talk about some techniques and best practices that you can use to build a high-performance e-commerce application using selling partner APIs. Some ground rules. There is a Q&A at the end of the session, so use your Slido to pop in your questions, and we'll take some time at the end of this presentation to answer some of those questions. Before we start, quick introduction. I'm Anjana. I'm a principal engineer in the Selling Partner API team, and have been with Amazon for 10 years, 7-ish years in the MWS Selling Partner API team, and I have with me Hina, our senior solution architect. You all probably know Hina very well, so she probably doesn't need any introductions. Yay! All right, before together we are going to talk a couple of things about scalability and reliability today. Starting from what it is and what it means and why is it important to some of the key techniques that you can use while building your applications. Keep in mind, this is not a talk about everything that you can do about building a reliable and scalable application. We have organized this talk into 3 key topics. And these topics are curated based on some of the access patterns that we have observed within Selling Partner APIs and the wealth of knowledge our solution architects team have figured out by working with all of you across the globe. Before we start, let's make sure we are all on the same page with respect to reliability and scalability. The first thing that pops into mind when we talk about reliable application is about its consistent performance. Here we are talking about predictable, stable, and consistent results that you can provide to your customers when they need it and where they need it. And the second one is about error handling. Your app should be able to gracefully handle errors. That just means retry behind the scenes when feasible, and show actionable error messages back to your customers when they need to fix something. The third thing about reliability is obviously about availability. You want your app to be available when the customers need it. Here we are talking about minimal downtimes. And thanks to many different techniques that we can use to make your apps reliable as we go. Right? Moving over to the other side, we're talking about scalability. The biggest thing that comes into mind when we talk about scalability is being able to handle growth. The growth of your customers, your customer demands, the use cases that they want to solve. Your app should be able to handle it as your customers grow. And while doing so, you want to make sure there is efficient usage of your resources. You don't want your resources to be bottlenecked when you are handling growth of your applications. And the third thing is about future-proofing. You don't want to spend a lot of time rewriting your applications or reworking on them when you have a net new technology or net new data that is available to you. You should be able to have right extensibility points that are hooked into your system to be able to extend to these use cases. Let's see why we should care. The first and foremost, it is about customer satisfaction. You don't want an unreliable application because that can impact your brand's reputation and customer trust. The second is about business continuity. Any outage is costly for your business. According to a Gartner survey, the cost of a downtime is $5.6K when we are talking about IT downtime. And this cost can quickly add up for your application as your outage minutes go. And the third thing, as usual, is about growth and flexibility. As you grow, you don't want your apps to be having a degradation in performance or bottlenecking of your resources when this happens. And let's put it in the context of selling partner APIs and see why is it important. At the end of the day, you are probably handling millions of transactions and terabytes of data on a day-to-day basis. And you are impacting millions of sellers across the globe. The number of sellers and vendors who are integrating with Amazon is growing. The number of sellers who are obviously using our apps are growing. Their demands and their needs are growing. You probably heard from some of our great sellers today. And you want to be able to grow with them. And they're relying on your apps for their business. And their business are probably livelihood of these sellers and probably hundreds of their employees. That by in itself is a great motivation for us to build a reliable and scalable application. And the third one is we are everywhere. Our customers are located all over the globe. Our selling partners are located all over the globe. You just want your applications to work 24/7. You don't want your employees to be awake and dealing with customer problems. You just want your app to work. Now let's come back to those 3 topics that I said we are organizing our conversation today on. The first one is fault tolerance. What that really means is you should be able to gracefully handle your failures. The second one is about handling overload. Here we are talking about lifetime of your app. You're probably going to get overloaded at some point in your time. All it probably requires is an amazing advertisement, a promotion, or a deal of a day to have hundreds of thousands of orders queued up in your apps for fulfillment. You want to be able to handle overload while making sure that you are not browning out your own systems, as well as not browning out your dependencies. And the third one is about efficient resource management. All of us are probably in cloud infrastructure today where we can probably auto scale and grow by demand. But at the end of the day, all of that is cost. You want to be able to judiciously use your resources in the best way possible. To do that, you should know the different ways in which you can access data from Amazon and which best data access mechanism is going to suit your use case is something you should be looking at closely. Let's dive into the first topic here, which is fault tolerance. This is pretty much saying failures will happen. There's nothing called a perfect hardware. There's nothing called a perfect network. There's nothing called a perfect dependency. Any of this can fail at any point in your application. And your application just should be able to deal with it. Before we dive into this topic, let's do a quick poll. Use your Slidos and see if you want to answer this question for us. Do you monitor your errors when making selling partner API requests? Here we are specifically talking about monitoring errors that you are receiving from selling partner APIs, not just about monitoring the overall health of your system. I'll give you a couple of minutes. All right, it looks like all of you do a great job at monitoring your systems. That's super awesome to know. Let's make sure that we are on the same page when it comes to how you handle these errors and how you monitor them and how you recover from the failures. The pie chart at the center of this slide is literally the distribution of our 4 excess errors that we see in selling partner APIs. A big chunk of these errors are coming from 429s, which is throttling. This basically says that you have reached your quota of using a particular API for a particular customer. Just blindly retrying these errors are not going to help you. You need to know how our throttling works and at what point your retries are going to be successful. If you don't do that, you're wasting your resources. memory, CPU, disk, network, all of that to do these retries. It's okay when your application is smaller, you can manage those costs. But as you scale and as you grow, these costs are going to quickly add up. So understanding what our 429 mean and what your rate of access is important for you to build an application. Sometimes you can surface this error very early to the customer itself that if they are the source of it. If it is an asynchronous job, smoothing out your traffic will get you out of these 429 situations very nicely without much investment. The other big part of our errors are 403s. They're unauthorized error. There's no point for you to retry this error at all. What the 403 error is saying is either the seller account or your application is in a stage where you are not able to access the data. Just retrying is not going to help. You need to find out the real root cause of this 403s. Sometimes even work with us to fix those issues before you can attempt retries. Again, like 429, just retrying or continuing to have this problem is not just a resource intensive on your side, but it is also going to degrade your customer experience. Then there are other two categories, which are like 400s and 404s. They are invalid input. Again, when your app is small, it's okay for you to come all the way back to selling partner APIs and get this error. But as your app grows, there are also opportunities for you to improve your performance. At the end of the day, I think what I'm trying to say here on the slide is that you should understand what each of the errors are coming out of selling partner APIs. Figure out what your monitoring mechanisms are and how to handle them appropriately. Now let's look at why should you monitor. Many of you already monitor, so I'm assuming all of you know the why behind it. But quickly capturing at the essence of it, it is customer obsession. We want to make sure we know how our apps are performing before customer does. You're probably very familiar with this correction of error documents that we as Amazon engineers write whenever we run into this problem. One persistent question that is being asked in that document is, how can you reduce the time to detection of this event by half? That question is very important because that helps develop a culture where consistently and proactively asking this question and remediating them iteratively, improving the customer experience at the end of it. So at the end of the day, what should you monitor? You should monitor all 500s that are coming out of selling partner APIs. You would think that a 500 from selling partner API means selling partner API is out of service or it's having some challenges. But that's not it. The 5XX can come because of issues at your end. It could be a DNS issue, a network issue, a hardware issue. All of this can come up as 500s in your selling partner API integration. So it's important for you to monitor them, act on them if the issue is on your side. The second one is about anomalies in all the 4XX that we talked about. If there is an increase in a 400 error, whether it is 429s or 400s or 404, that's indicating to you that you have probably deployed something that is creating a pathway for increased customer errors. And it is important for you to monitor it, identify where that pathway was created, and remediate it. And you should also monitor all of your retries as well. Just completely retrying it on one part of the application can impact other part of your application. And it's mostly important if you are using the same APIs across different parts of your applications. So in a sense, I think what monitoring is getting you is not just finding issues when they occur. It is an opportunity for you to understand deeply about your system and iteratively continue to improve it. Now let's look into some techniques that we want to cover as part of recovering from these failures. Some of these failures, you as an engineer or an IT professional, you probably need to want to be woken up to fix those issues. But there are certain issues that may not be that critical and it can self-recover. Here we are talking about two key strategies. One is caching that Hina will cover in some of the next slides. But the second strategy that we are talking about is retries. Fundamentally, you need to understand what errors can be retried and what cannot be. At a very high level, you would assume all the 5xx can be retried. But that's not all it. 5xx, when they are intermittent, retrying is successful. But if your dependency is in distress or you have a core problem with your network, just retrying is not going to help. So it is very important for you to use some techniques while you are retrying, which includes capping the number of retries, pausing between retries, and sometimes even gracefully handling those errors. Or use techniques like circuit breakers so that you are not overpowering the systems that is already under distress. So overall, I think from this section, what we are trying to say is failures are going to happen. You need to know what errors are going to come out of SP API. And you should learn how to efficiently handle those errors in a way that is not costly for your systems. From here, I'll hand it over to Hina to cover the next two topics that we wanted to cover as part of building a scalable application.
Thank you, Anjana.
And keep that Q&A coming from the Slidos.
Hi, everyone. Let's get to... OK. Handling overload. Handling overload effectively is crucial to maintain your application's performance during peak demands and during general cycles. Let's look into that and how we can do it. Building reliably. Building for reliability involves many things that Anjana talked about, from handling errors, also using global exception handlers for unexpected errors. But there's another thing that you can do is understand and automating your quota protections and how you can leverage those with SP API. Each SP API endpoint has its maximum quota limit and a restore rate. Leveraging and implementing an automated mechanism to implement these resources effectively is one way you can ensure that you are in the rate limits of each of the APIs. We can ensure our application are using efficient resources, and this helps you avoid unnecessary throttling errors. Rate limits are provided to you for each application operation, which you can build in a manner to scale up to those limits. Next, we have scalability. Building for scalability is one of the fundamental modern application designs, and especially for systems like SP API and your applications that need to be able to handle varying loads of data over time. Load balancing is one of the first techniques you can use to ensure that you have a scalable system. This involves essentially implementing multiple servers for your application so no one single server becomes a bottleneck. This not only enhances the responsiveness and availability of your application, but also allows our systems and your app to handle more data and more load over time. Next, we have autoscaling. Autoscaling is a powerful technique that allows our system to automatically adjust its computational resources over time to handle demand. This optimizes resource usage and ensures consistent performance. Your system is able to scale up and scale down based on the traffic and demand. The next thing we have here is prioritizing workloads based on business criticality. This is essential when you have a high demand period going on. You may need to prioritize certain tasks over others to ensure that the most important critical tasks are completed first. This can be achieved using techniques like load shedding and using priority queues. We'll discuss more on this in our next slide. Let's mention caching. Implementing caching mechanisms is critical to make sure that your applications are able to improve significantly for performance and scalability. Caching can involve storing request data from one request for your future operations. This reduces the net load on your servers and our servers and speeds up the data retrieval process over time. As mentioned, load shedding is one of the key things that you can do to cheaply reject excess work, and prioritize important work. Sending more and more load to a server isn't always the best approach. This can result in a steep decline in performance when the system is already operating at a maximum capacity. This leads to latency issues, timeouts, user dissatisfaction. We don't want that. Instead of overwhelming the server, we can spread out our traffic and smoothen the spikes. This is essentially you maintaining a consistent traffic patterns over time and avoiding the spiky graph that you see there. This can be achieved by using the rate limits. You can use messaging queues. You can also leverage to schedule non-critical work during off-peak hours. This approach also helps you prioritize important work and reject less important tasks. This allows the focus on critical tasks and ensuring that all your tasks and requests get completed in a timely manner over the period of time. In essence, load shedding is mainly about maintaining a balance across your servers, ensuring that all your calls and all your responses are scheduled in a manner that is scheduled over a period of time, allows you to manage your resources effectively and prioritizing important tasks. Building efficient SPA API integration. Let's look into how we can do that. But let's first look at some of the common data access patterns we see across all of our applications. We only see use of one-on-one operations, mostly sending synchronous feed requests, not relying on notifications or event-driven architecture. And we can optimize this based on the different access patterns we have available and event-driven notifications. Consider using and implementing event-driven architecture. SPA API has over 20 plus different notification types available based on Amazon SQS and EventBridge. Reacting to relevant notifications and events can lead to faster response times, which leads to more efficient use of resources and reduces your throttling issues. An example here would be order change notification that can be a game changer for anyone who calls Orders API and is hit by a throttling error. This recently released notification now includes an item-level payload, but also informs you when there's a buyer-level cancellation, so you can take necessary actions as needed. Another example that I would like to mention is if you guys are calling any of our retail analytics or brand analytics reports, and we have heard feedback where you're not able to get notifications on when there's a change in data set. We have released real-time data reports on these, and along with them, there are notifications available, which can inform you if there's a change in data for an already requested data set, which otherwise you would have to pull for information later on when you find a mismatch in data set or an issue reported. I also want to mention, with notifications, you only have to subscribe for a notification type per seller once. And you can delete the notification based on if the seller is no longer using your services or for other reasons that may not require you to listen to their events. Next, we have best suited API access methods. We have different variations of access methods available, from one-on-one endpoints to batch to bulk operations. Use batch operations whenever possible. They allow you to get access to bulk data and reduces the number of individual API calls you'll have to make. This reduces the number of requests you'll make and decreases the total time to completion of your calls. And this ends up optimizing resources. Let's talk about reports. Reports are a powerful tool that you can use to get bulk data access. We allow reports on demand, but also on schedule. There are a variety of reports available, from inventory tracking, order management, tax information, seller performance, and many, many more. You can request reports on demand, but also schedule reports like order reports, where you're able to get notified using the report processing notification when a report is available. Reports are a great way to use when you are doing a data backfill or in times of peak where like Prime Day or Black Friday. These are great operations you can use along with the one-on-one operations to get that data in bulk in a single request. Next, we have feeds. Feeds allow you to publish data to Amazon, which greatly enhances the efficiency of data-heavy operations. Feeds operate asynchronously, which means when you submit a feed, you don't get a response back immediately. The feeds are being processed in the background, and you can subscribe to the notification for feeds processing to be notified when the feed is done. You want to be considerate of the sequencing of your feed types you submit. Feeds are processed sequentially, so as you're submitting your feed types, you want to make sure that you're optimizing them by size and by the type of feeds that you're sending to us. To handle this, you can optimize the sizing for different types of feeds because some feeds at times are dependent on other feeds processing to complete before they can actually start. So you want to keep that in mind when you're submitting all the different requests. Another example that I would give here is when you're submitting shipping confirmation for merchant fulfill orders. We have a feed type, order acknowledgement feed, but we also have released recently an API operation called order ship confirm with orders API. So if you're confirming orders for a bulk orders, you want to leverage the feed. But if you're doing smaller batches, one-on-one endpoint might be the better option for you there. Ultimately, optimizing API performance is about making decisions based specific to your application. Using the right API endpoints, using event-driven architecture, using batch operations can make your SP API application more efficient and effective. With that, in the beginning of this presentation, we had promised you 3 takeaways. We want you to design for failure. We want you to monitor your errors, your 4XX errors, and optimize accordingly based on the learnings we get, and choosing the right access patterns. We have different variations for each API, reports, and batches, so you want to be able to use different based on specific use cases for your application. With that, thank you for your attention, and I hope this session was helpful.